All or Underwriters Laboratories does not maintain a specific standard dedicated solely to electrical installations concerning food safety. However, several other organizations offer pertinent standards and guidelines. Firstly, the International Organization for Standardization, or ISA, offers relevant standards. ISO 22000.2018, titled Food Safety Management Systems, a circumflex requirements for any organization in the food chain, provides a framework for managing food safety risks. ISO 22004.2014, Food Safety Management Systems, a circumflex the application of ISO 22000.2005 to small and medium-sized organizations, offers guidance for implementing ISO 22000. Secondly, the Institute of Electrical and Electronics Engineers, or IEEE, has a relevant standard. IEEE 1584-2018, Guide for Electrical Installations in Chemical Processing and Petrochemical Plants, offers guidance for electrical installations in hazardous, classified areas, which can be applicable to specific zones within food processing facilities. Thirdly, NSF International, formerly the National Sanitation Foundation, provides standards related to food equipment. NSF/ANSI 2.2018 addresses food equipment. NSF/ANSI 8.2020 covers commercial cooking, vending, and warewashing equipment. NSF/ANSI 12.2018 focuses on commercial refrigerators and freezers. In addition to these standards, resources are available from other organizations. The Food and Drug Administration, or FDA, through the Food Safety Modernization Act, or FSMA, provides regulations and guidance on food safety, including sanitary design principles for food facilities. The British Retail Consortium, or BRC, Global Food Safety Standard includes requirements for electrical installations in food processing environments. The International Electrotechnical Commission, or IEEE, publication 60364-7-710, Electrical Installations of Buildings, a circumflex parts EVA-710 requirements for special installations or locations, a circumflex foodstuffs industries, provides specific requirements for electrical installations in food processing facilities, mainly applicable in Europe. When designing and installing electrical systems in food processing plants, adherence to these standards and guidelines ensures compliance with food safety regulations and minimizes the risk of contamination or hazards. For selecting appropriate materials, consider the following. Stainless steel is often favored for its corrosion resistance and cleanability. Enclosures should be sloped to prevent accumulation of debris and moisture. Avoiding all thread rods and using alternative support systems can reduce harborage points for bacteria. Shatterproof light fixtures are essential to prevent glass contamination in case of breakage. These best practices, combined with the requirements outlined in the aforementioned standards, contribute to a safe and hygienic food processing environment. Understanding these standards and guidelines is crucial for engineers, facility managers, and anyone involved in the design, installation, or maintenance of electrical systems in food processing facilities. The goal is to minimize risks, maintain hygiene, and comply with regulations to ensure food safety. To elaborate further on each organization and its contributions, let's consider the FDA role. The FDA, through the Food Safety Modernization Act, or FSMA, has significantly reshaped food safety regulations in the United States. FSMA emphasizes preventive controls, requiring food facilities to identify potential hazards and implement measures to prevent or minimize contamination. The sanitary design of food facilities is a key component of FSMA. Electrical systems must be designed and installed to prevent harborage of bacteria, facilitate cleaning, and minimize the risk of electrical hazards. Next, the BRC Global Food Safety Standard is a widely recognized benchmark for food safety. This standard includes requirements for electrical installations, ensuring that they meet hygiene and safety standards. The BRC standard covers various aspects of electrical systems, including wiring, lighting, and equipment grounding. It also emphasizes the importance of regular inspections and maintenance to ensure that electrical systems remain in good working order. Moving on to the IEC publication 60000. 364-7-710 offers specific requirements for electrical installations in food processing facilities. This standard addresses various aspects of electrical safety, including protection against electric shock, prevention of fire hazards, and minimization of electromagnetic interference. It also includes guidelines for selecting appropriate electrical equipment and materials for use in food processing environments. Now, let's delve into some specific considerations for electrical installations in food processing facilities. Firstly, wiring systems should be designed and installed to prevent contamination of food products. This includes using appropriate wiring methods such as conduit or cable trays, and sealing all penetrations to prevent the entry of moisture and pests. Secondly, lighting is a critical aspect of food safety. Light fixtures should be shatterproof or equipped with protective shields to prevent glass contamination in case of breakage. The intensity and color of lighting should also be appropriate for the task at hand, ensuring that workers can properly inspect food products for defects or contamination. Thirdly, electrical equipment should be designed and installed to facilitate cleaning and sanitation. This includes using smooth, non-porous materials that are easy to clean and disinfect. Equipment should also be designed to prevent the accumulation of debris and moisture. Fourthly, grounding and bonding are essential for electrical safety. Proper grounding and bonding can prevent electric shock hazards and minimize the risk of fire. All electrical equipment should be properly grounded, and bonding should be used to connect metal parts of the electrical system. Fifthly, electrical panels and enclosures should be designed to protect against the ingress of water and dust. This is particularly important in food processing environments where equipment is frequently washed down. Enclosures should be rated for the appropriate environmental conditions such as NEMA 4X for wet environments. Sixthly, regular inspections and maintenance are essential for ensuring the ongoing safety and reliability of electrical systems in food processing facilities. Inspections should be conducted by qualified electricians, and any defects or deficiencies should be promptly corrected. Maintenance should include cleaning, tightening connections, and testing equipment to ensure that it is functioning properly. Furthermore, arc flash hazard analysis should be conducted to determine the potential arc flash hazards in the facility. This analysis can help to identify areas where additional protective measures are needed, such as arc flash barriers or personal protective equipment. Training is also a critical component of electrical safety in food processing facilities. Workers should be trained on the hazards of electricity and the proper procedures for working with electrical equipment. They should also be trained on the use of personal protective equipment and the importance of following safety guidelines. In summary, ensuring electrical safety in food processing facilities requires a comprehensive approach that encompasses design, installation, maintenance, and training. By following the standards and guidelines provided by organizations such as UL, IEEE, IEEE, NSF International, FDA, BRC, and IEEE, food processing facilities can minimize the risk of electrical hazards and maintain a safe and hygienic environment. The selection of materials plays a crucial role in maintaining hygiene and preventing contamination. Stainless steel is widely used due to its resistance to corrosion and ease of cleaning. It can withstand frequent washdowns and exposure to cleaning agents without degrading. Sloped enclosures prevent the accumulation of water and debris, reducing the risk of bacterial growth. Avoiding all thread and using alternative support systems minimizes harborage points for bacteria, as all thread can be difficult to clean thoroughly. Shatterproof light fixtures are essential to prevent glass contamination in the event of breakage. These fixtures are designed to contain glass shards, preventing them from falling into food product. The design of electrical equipment should also consider ease of access for cleaning and maintenance. Equipment should be designed with smooth surfaces and minimal crevices to prevent the accumulation of dirt and debris. Electrical panels and enclosures should be sealed to prevent the ingress of water and pests. The location of electrical equipment should also be carefully considered. Equipment should be located away from areas where food is processed or stored to minimize the risk of contamination. In addition to material selection and equipment design, proper installation practices are essential for maintaining electrical safety and hygiene. Wiring should be installed in conduit or cable trays to protect it from damage and prevent the accumulation of dust and debris. All connections should be properly tightened and insulated to prevent electrical hazards. Grounding and bonding are essential for electrical safety and should be performed in accordance with applicable codes and standards. Regular inspections and maintenance are crucial for ensuring the ongoing safety and reliability of electrical systems in food processing facilities. Inspections should be performed by qualified electricians who are familiar with the specific requirements of food processing environments. Maintenance should include cleaning, tightening connections, and testing equipment to ensure that it is functioning properly. Any deficiencies or hazards should be promptly corrected to prevent accidents and maintain food safety. In addition to the technical aspects of electrical installations, it is important to consider the human factors that can contribute to electrical accidents. Workers should be properly trained on the hazards of electricity and the safe work practices that should be followed. They should also be provided with appropriate personal protective equipment, such as gloves, safety glasses, and arc flash suits. Communication is also essential for preventing electrical accidents. Workers should be encouraged to report any hazards or concerns to their supervisors. Regular safety meetings should be held to discuss electrical safety topics and reinforce safe work practices. Finally, it is important to foster a culture of safety in the workplace. Management should demonstrate a commitment to safety and provide the resources necessary to ensure that electrical systems are properly designed, installed, and maintained. Workers should be empowered to take ownership of their own safety and the safety of their colleagues. By implementing these measures, food processing facilities can minimize the risk of electrical accidents and maintain a safe and hygienic environment for workers and consumers. The NEC, or National Electrical Code, provides comprehensive guidelines for electrical installations. While it doesn't specifically address food processing, it provides a foundation for safe electrical practices applicable to all environments. Refer to the NEC for general requirements on wiring methods, overcurrent protection, grounding, and equipment installation. The applicable articles in the NEC should be followed in conjunction with other food safety standards to ensure a compliant installation. Consider, for example, NEC Article 250, which covers grounding and bonding. Proper grounding is critical to prevent electrical shock hazards and ensure the reliable operation of equipment. In food processing environments, where equipment is frequently washed down, grounding systems must be robust and corrosion resistant. Similarly, NEC Article 300 addresses wiring methods. In food processing facilities, wiring must be protected from physical damage and exposure to moisture and chemicals. This may require the use of rigid metal conduit or liquid-tight flexible metal conduit. The selection of appropriate wiring methods should be based on the specific environmental conditions of the facility. Overcurrent protection is another critical aspect of electrical safety. NEC Article 240 provides requirements for overcurrent protection devices, such as fuses and circuit breakers. These devices are designed to protect electrical circuits from overloads and short circuits, preventing fires and other hazards. In food processing facilities, overcurrent protection devices must be readily accessible and properly maintained. The selection of appropriate overcurrent protection devices should be based on the specific characteristics of the electrical circuits they are protecting. Another key consideration is the selection of electrical equipment for use in food processing environments. Equipment should be designed and constructed to withstand the harsh conditions found in these facilities. This may require the use of stainless steel enclosures, waterproof connectors, and other specialized components. Equipment should also be easy to clean and sanitize to prevent the growth of bacteria and other microorganisms. Lighting is another important aspect of electrical design in food processing facilities. Lighting should be adequate to provide good visibility for workers, but it should also be designed to minimize the risk of contamination. Light fixtures should be shatterproof or equipped with protective shields to prevent glass from falling into food products. The color temperature of the lighting should also be appropriate for the task at hand. In addition to the NEC, there are other codes and standards that may be applicable to electrical installations in food processing facilities. These may include local building codes, fire codes, and health codes. It is important to consult with local authorities to determine which codes and standards are applicable to a specific project. The design and installation of electrical systems in food processing facilities should be performed by qualified electricians who are familiar with the specific requirements of these environments. The electricians should have experience working with stainless steel conduit, waterproof connectors, and other specialized components. They should also be knowledgeable about the applicable codes and standards. Regular inspections and maintenance are essential for ensuring the ongoing safety and reliability of electrical systems in food processing facilities. Inspections should be performed by qualified electricians who are familiar with the specific requirements of these environments. Maintenance should include cleaning, tightening connections, and testing equipment to ensure that it is functioning properly. Any deficiencies or hazards should be promptly corrected to prevent accidents and maintain food safety. Electrical safety in food processing facilities is a complex and multifaceted issue. It requires a thorough understanding of electrical codes and standards, as well as the specific requirements of food processing environments. By following the guidelines outlined in this overview, food processing facilities can minimize the risk of electrical hazards and maintain a safe and hygienic environment for workers and consumers. Electrical installations in food processing facilities are subject to unique challenges because of the presence of moisture, corrosive substances, and stringent sanitation requirements. Let's delve deeper into specific electrical components and their application in these environments. Conduit systems are the backbone of electrical protection. Stainless steel conduit is often preferred for its corrosion resistance, especially in areas exposed to frequent washdowns. PVC conduit offers an alternative in certain applications, but its suitability depends on the specific chemicals and temperatures present. Proper sealing of conduit joints and connections is critical to prevent moisture ingress. Fittings should be rated for wet locations and installed with appropriate sealing compounds. Wiring selection should consider the ambient temperature and potential exposure to chemicals. THHN/THWN-2 conductors are commonly used, but specific applications may require more specialized insulation types. Cable trays can be used to support and route multiple cables, but they should be designed to prevent the accumulation of debris and facilitate cleaning. Cable glands provide a secure and watertight connection between cables and enclosures. They should be selected based on the cable diameter and environmental conditions. Enclosures house electrical components and protect them from the environment. Stainless steel enclosures are preferred in food processing facilities due to their corrosion resistance and cleanability. Enclosures should be rated for the appropriate NEMA type, such as NEMA 4X for wet locations. Doors should be gasketed to prevent the entry of moisture and dust. Disconnect switches provide a means of safely de-energizing electrical circuits for maintenance or repair. They should be readily accessible and clearly labeled. Motor starters control the starting and stopping of electric motors. They should be selected based on the motor horsepower and voltage. Ground fault circuit interrupters, or GFCIs, protect personnel from electric shock by detecting ground faults. They are required in wet locations and areas where electrical equipment is likely to come into contact with water. Lighting fixtures should provide adequate illumination while minimizing the risk of contamination. Shatterproof or shielded fixtures are recommended to prevent glass from falling into food products. LED lighting is energy efficient and long-lasting, making it a popular choice for food processing facilities. Emergency lighting ensures that workers can safely evacuate the facility in the event of a power outage. Emergency lighting systems should be tested regularly to ensure that they are functioning properly. Fire alarm systems protect the facility from fire hazards. Fire alarm systems should be designed and installed in accordance with applicable codes and standards. Regular testing and maintenance are essential to ensure that the fire alarm system is functioning properly. Surge protection devices, or SPDs, protect electrical equipment from voltage surges caused by lightning or other events. SPD should be installed at the service entrance and at sensitive equipment locations. Power distribution units, or PDUs, distribute power to multiple loads. PDU should be selected based on the load requirements and environmental conditions. Transformers step up or step down voltage levels. Transformers should be selected based on the voltage requirements of the equipment being served. Regular inspections and maintenance are crucial for ensuring the ongoing safety and reliability of electrical systems in food processing facilities. Inspections should be performed by qualified electricians who are familiar with the specific requirements of these environments. Maintenance should include cleaning, tightening connections, and testing equipment to ensure that it is functioning properly. Any deficiencies or hazards should be promptly corrected to prevent accidents and maintain food safety. Electrical safety in food processing facilities is a shared responsibility. Management, employees, and contractors all play a role in ensuring that electrical systems are safe and reliable. Training is essential for all personnel who work with or around electrical equipment. Training should cover the hazards of electricity, safe work practices, and the proper use of personal protective equipment. Communication is also critical. Employees should be encouraged to report any electrical hazards or concerns to their supervisors. Regular safety meetings should be held to discuss electrical safety topics and reinforce safe work practices. By working together, we can create a safe and productive environment for everyone in the food processing industry. Now, let's move on to specific design considerations for electrical systems in food processing environments. One crucial aspect is zoning and classification. Food processing facilities are often divided into different zones based on the level of sanitation required. These zones may include raw material receiving areas, processing areas, packaging areas, and storage areas. Each zone may have different electrical requirements based on the potential for exposure to moisture, chemicals, and other contaminants. For example, areas where raw materials are processed may require more stringent sanitation measures than areas where packaged products are stored. Another important consideration is the layout of electrical equipment. Equipment should be located in areas that are easily accessible for cleaning and maintenance. It should also be located away from areas where food is processed or stored to minimize the risk of contamination. Wiring should be routed in a manner that minimizes the potential for contact with food products. Cable trays should be used to support and route multiple cables, but they should be designed to prevent the accumulation of debris and facilitate cleaning. Lighting should be designed to provide adequate illumination while minimizing the risk of contamination. Light fixtures should be shatterproof or shielded to prevent glass from falling into food products. The color temperature of the lighting should also be appropriate for the task at hand. Grounding and bonding are essential for electrical safety and should be performed in accordance with applicable codes and standards. Proper grounding can prevent electric shock hazards and minimize the risk of fire. Bonding is used to connect metal parts of the electrical system, creating a low impedance path for fault currents. Surge protection is another important consideration. Voltage surges can damage sensitive electronic equipment and disrupt operations. Surge protection devices should be installed at the service entrance and at sensitive equipment locations. Power quality is also a concern in food processing facilities. Electrical equipment can be sensitive to voltage fluctuations, harmonics, and other power quality disturbances. Power quality monitoring equipment can be used to identify and address power quality problems. Energy efficiency is becoming increasingly important in food processing facilities. Energy-efficient lighting, motors, and other equipment can help to reduce energy consumption and lower operating costs. Renewable energy sources, such as solar panels, can also be used to generate electricity and reduce reliance on fossil fuels. Commissioning is the process of verifying that electrical systems are installed and functioning properly. Commissioning should be performed by qualified personnel who are familiar with the specific requirements of food processing environments. Regular inspections and maintenance are essential for ensuring the ongoing safety and reliability of electrical systems in food processing facilities. Inspections should be performed by qualified electricians who are familiar with the specific requirements of these environments. Maintenance should include cleaning, tightening connections, and testing equipment to ensure that it is functioning properly. Any deficiencies or hazards should be promptly corrected to prevent accidents and maintain food safety. Now let's address grounding and bonding systems. The primary purpose of grounding is to provide a low impedance path for fault currents to return to the source. This helps to quickly trip over current protection devices, such as circuit breakers or fuses, in the event of a ground fault. Proper grounding also helps to minimize the risk of electric shock by providing a path for fault currents to flow to ground rather than through a person. Bonding is the process of connecting all metal parts of the electrical system together to create a low impedance path for fault currents. This helps to ensure that all metal parts are at the same potential, minimizing the risk of electric shock. Bonding also helps to reduce electromagnetic interference, or EMI, which can disrupt the operation of sensitive electronic equipment. Grounding and bonding systems should be designed and installed in accordance with applicable codes and standards, such as the NEC. The NEC provides detailed requirements for grounding and bonding, including the size and type of grounding conductors, the location of ground rods, and the methods for bonding metal parts. In food processing facilities, grounding and bonding systems must be particularly robust to withstand the harsh environmental conditions. Stainless steel grounding conductors and connectors are often used to resist corrosion. Ground rods should be driven deep into the ground to ensure good contact with the earth. Bonding jumpers should be used to connect all metal parts of the electrical system, including conduit, enclosures, and equipment. Regular inspections and testing of grounding and bonding systems are essential to ensure that they are functioning properly. Ground resistance testing should be performed to verify that the grounding system has a low impedance to ground. Bonding jumpers should be inspected to ensure that they are securely connected and free from corrosion. Any deficiencies or hazards should be promptly corrected to prevent electrical accidents. Let's turn to arc flash hazards and mitigation. An arc flash is a dangerous electrical explosion that can occur when there is a short circuit or other electrical fault. Arc flashes can generate intense heat pressure waves and molten metal, which can cause serious injuries or even death. Arc flash hazards are particularly prevalent in electrical systems with high voltage and current levels. Food processing facilities often have large electrical systems that power motors, pumps, and other equipment, which can increase the risk of arc flashes. To mitigate the arc flash hazards, it is essential to conduct an arc flash hazard analysis. An arc flash hazard analysis is a study that identifies potential arc flash hazards and determines the level of protection required. The analysis should consider factors such as the voltage and current levels, a clearing time of overcurrent protection devices, and the working distance of personnel. Based on the results of the arc flash hazard analysis, appropriate protective measures can be implemented. These measures may include the use of arc-rated personal protective equipment, or PPE, such as arc flash suits, gloves, and face shields. Other protective measures may include the installation of arc flash barriers, the use of remote racking systems, and the implementation of lockout/tag-up procedures. Training is also essential for mitigating arc flash hazards. Personnel who work with or around electrical equipment should be trained on the hazards of arc flashes and the proper use of PPE. They should also be trained on the procedures for de-energizing equipment and performing work safely. Regular inspections and maintenance of electrical equipment can also help to prevent arc flashes. Equipment should be inspected for signs of damage or wear, and any deficiencies should be promptly corrected. Overcurrent protection devices should be tested to ensure that they are functioning properly. By taking these steps, food processing facilities can significantly reduce the risk of arc flash incidents and protect their workers from serious injuries or death. Another aspect to consider is hygienic design principles for electrical equipment. Hygienic design is the application of engineering principles to design equipment and facilities that are easy to clean and sanitize, minimizing the risk of contamination. Hygienic design is particularly important in food processing facilities where equipment comes into direct contact with food products. Electrical equipment should be designed with smooth surfaces and rounded corners to prevent the accumulation of dirt and debris. Equipment should also be designed to be easily disassembled for cleaning and sanitizing. Materials should be selected that are resistant to corrosion and can withstand frequent cleaning. Enclosures should be sealed to prevent the entry of water and other contaminants. Wiring should be routed in a manner that minimizes the potential for contact with food product. Cable trays should be designed to be easily cleaned and sanitized. Light fixtures should be shatterproof or shielded to prevent glass from falling into food products. Equipment should be located in areas that are easily accessible for cleaning and maintenance. Hygienic design principles should be considered throughout the design, installation, and maintenance of electrical systems and food processing facilities. By following these principles, food processing facilities can minimize the risk of contamination and ensure the safety of their products.